At first, it seemed like nothing more than a minor geological anomaly, a subtle shift in the Earth, a barely noticeable crack appearing in the landscape. But over time, what began as a small fracture has grown into something far more ominous. The ground itself is pulling apart, forming a vast and expanding chasm that stretches across South America. Scientists are watching in disbelief as an event once thought impossible unfolds before their eyes. The continent, home to lush rainforests, ancient civilizations, and some of the most diverse ecosystems on Earth, is now facing an unprecedented crisis. A literal crack is forming, one that is not just splitting the land, but threatening the very stability of entire regions. Experts warn that this could be a sign of something far greater, a deep tectonic shift that might reshape South America's geography forever. Could this be the beginning of a slow-motion disaster? Is the continent on the verge of a catastrophic break? The answers are not simple, but the facts are undeniable. Scientists have long understood that the forces beneath the Earth's crust are in constant motion, grinding, stretching, and reshaping the planet over millions of years. But what is happening in South America is unfolding at an alarming rate, much faster than standard geological processes should allow. Entire communities are beginning to feel the effects, roads cracking apart, rivers altering their course, and once stable ground becoming dangerously unstable. As the crack grows wider, questions emerge that demand immediate attention. What is causing this sudden and dramatic rupture? Is it a sign of a deeper, more destructive force at play? And most importantly, how will this impact the people, cities, and economies that depend on stable land? One of the first indicators that something unusual was happening came from satellite imagery. At first, it appeared as little more than a faint line, a subtle scar across the terrain. But as weeks turned into months, that scar became more pronounced. What started as a barely visible fissure has expanded into a deep, growing chasm, cutting through forests, farms, and even approaching inhabited areas. Some geologists compare it to the East African Rift, a massive continental divide that is slowly tearing Africa apart. But what is happening in South America is accelerating at a speed no one expected. Deep underground, something is shifting. Seismic activity in the region has seen an unusual spike, with tremors occurring in areas that have historically been geologically stable. Some experts believe that the entire tectonic structure beneath the continent is undergoing a radical change. Could this be the early stages of a continental split? A new ocean forming in the middle of South America? The implications are staggering. The Andes Mountains, one of the most defining features of the continent, may hold some of the answers. This colossal mountain range, formed by the collision of tectonic plates over millions of years, has long been a geological hotspot. But recent findings suggest that the forces responsible for creating the Andes may now be working in reverse, pulling the continent apart rather than pushing it together. This shift is generating immense stress within the Earth's crust, and the result is the growing fracture that is now making headlines. Geologists are racing against time to study the phenomenon. They are deploying instruments along the fault zones, measuring the rate of expansion, and monitoring for signs of further destabilization. The crack itself is not just a passive feature, it is an active, evolving structure that is responding to forces far beneath the surface. And what they are discovering is nothing short of alarming. Some regions near the fissure have experienced sudden ground collapses, swallowing roads, buildings, and farmland without warning. Entire communities have been forced to evacuate as their homes become uninhabitable. In certain areas, the land is sinking, indicating that underground voids are forming, possibly due to magma movement or underground water displacement. These are the kinds of warning signs that precede massive geological upheavals. Local governments are now faced with impossible decisions. Should they begin relocating entire towns that lie within the path of the crack? Should they invest in massive infrastructure projects to try and reinforce the land, even though it may ultimately prove futile? And what about the millions of people living in major cities near the fault line? How long before they begin to feel the effects? Meanwhile, the scientific community remains divided. Some argue that this is a slow, natural process that could take thousands or even millions of years to fully unfold. Others, however, believe that this could be the early stages of a dramatic event that may escalate within our lifetime. The terrifying possibility that an entirely new body of water could one day separate South America into two distinct landmasses is no longer science fiction. It is a scenario that some researchers are beginning to take seriously. The growing crack has also caught the attention of international agencies. NASA, for example, has redirected some of its Earth monitoring satellites to closely observe the changes in South America's landmass. They are using cutting-edge technology to map the movements of the tectonic plates in real time, looking for signs of acceleration or unexpected shifts. So far, the data has confirmed what geologists feared. The crack is expanding, and it is doing so at an unpredictable rate. The question now is not just what is causing this, but what comes next. If this rupture continues to grow, could it one day become an ocean? Could the land masses on either side of the crack drift apart, leading to the birth of a new island continent? The thought alone is enough to send shockwaves through both the scientific world and the global economy. The implications for trade, infrastructure, and geopolitics would be immense. What is happening in South America right now is a reminder of just how fragile and dynamic our planet truly is. We often think of the ground beneath us as stable, unchanging, but history tells a different story. Continents shift, land masses break apart, and new geological features are constantly being formed. What we are witnessing today in South America may be one of the most dramatic examples of this process in modern history. The crack continues to grow. The warnings are being sounded. And yet, we are left with more questions than answers. Could we be witnessing the first stages of a split that will forever change the map of the world? Or is this merely a temporary geological event, one that will stabilize over time, leaving only a scar across the land as a reminder of the forces lurking beneath our feet? One thing is certain, the Earth is always changing, whether we are prepared for it or not. And as scientists continue to monitor this unfolding mystery, the rest of the world watches, waiting to see what will happen next. The mystery surrounding the growing crack in South America deepens as researchers scramble to understand its origins and potential consequences. What was once thought to be a slow-moving geological shift now appears to be accelerating. The scientific community is in a race against time, gathering data, analyzing satellite imagery, and deploying field teams to assess the true scope of this unfolding catastrophe. Yet, for every answer they uncover, more unsettling questions emerge. Local communities living near the fracture have reported eerie signs of the Earth's instability, strange noises echoing from deep below the surface, tremors shaking the ground with increasing frequency, and in some areas, entire sections of land seemingly sinking overnight. These are not isolated incidents. They are part of a larger, more ominous pattern. Reports have surfaced of rivers suddenly changing course, roads that were once stable now riddled with deep fissures, and even farmland collapsing into hidden voids below. One of the most troubling aspects of this phenomenon is its unpredictability. Scientists have documented similar rift formations in other parts of the world, such as the Great Rift Valley in Africa, where a similar process is slowly splitting the continent apart. But what's happening in South America is progressing at an unsettling speed. Some geologists believe that hidden forces beneath the surface, perhaps an enormous, unseen shift in the tectonic plates, could be accelerating the process. Deep within the Earth's crust, the South American plate and the Nazca plate have been locked in a slow-motion collision for millions of years. This ongoing pressure has created the towering Andes Mountains, a geological marvel that defines the continent's western edge. But now, it appears that the pressure between these plates is no longer pushing upward. Instead, it may be pulling apart. If this is true, then South America could be experiencing the early stages of a rift event that could one day split the continent into two. The consequences of such an event would be staggering. The formation of a new ocean in the middle of South America might sound like something from a science fiction novel, but geologists cannot ignore the similarities to other known rift zones. If the crack continues to expand, water from the Atlantic could eventually rush in, forever dividing the continent. The Amazon rainforest, the world's largest and most vital source of oxygen, could be permanently altered. millions of people could find themselves displaced as entire cities fall victim to the shifting earth beneath their feet. Governments are beginning to take notice. In Brazil, emergency response teams are being mobilized to assess the growing number of displaced communities. In Peru and Bolivia, officials are consulting with leading geologists to determine whether preemptive evacuations should be considered. Ecuador, which lies dangerously close to the expanding fissure, has already begun reinforcing infrastructure in anticipation of future seismic activity. Yet, despite these efforts, no one truly knows what will happen next. Some researchers believe that this could be part of a natural cycle, one that has played out many times throughout Earth's history. They argue that while the crack may continue to grow, it could stabilize over time, leaving behind nothing more than a dramatic scar across the continent. Others, however, are far less optimistic. They fear that the increasing seismic activity, the rapid expansion of the fissure, and the sheer unpredictability of the event suggest that this could be the beginning of something much larger. Adding to the concern, satellite data from NASA has revealed an anomaly deep beneath the crack, a vast region of magma movement that was previously undetected. If this molten rock is rising toward the surface, it could indicate that the rift is not just a product of shifting tectonic plates, but is also being fueled by volcanic activity. If true, then South America might not just be splitting apart, it could also be on the brink of experiencing massive volcanic eruptions, further compounding the disaster. In the scientific community, debates rage over what this means. Some argue that this is nothing more than a natural fluctuation in the Earth's geology, an event that will stabilize over thousands of years. Others warn that we are witnessing the early warning signs of a transformation that could take place within decades, not millennia. For those living near the growing chasm, however, the time frame is of little comfort. They are witnessing the effects firsthand: homes lost, land crumbling, and an overwhelming sense of uncertainty. Reports of underground water sources drying up or becoming contaminated suggest that subterranean shifts are already disrupting vital resources. Crops are failing in some regions as the land itself changes in ways that no one can predict. The world watches as this story unfolds, waiting for answers that may not come in time. Will this growing rift become the birthplace of a new ocean? Or is it simply another chapter in the ever-changing history of our planet? No one can say for certain. But what is undeniable is that South America is facing a geological mystery unlike anything we've ever seen before. One of the most pressing theories behind the massive crack splitting South America involves deep-seated tectonic activity, forces within the Earth that have been at play for millions of years but may now be accelerating due to unforeseen conditions. While tectonic shifts are a well-known phenomenon, what's occurring in South America appears to be an extreme and highly unusual case, raising alarms among geologists worldwide. At the heart of this geological puzzle lies the South American Plate and the Nazca Plate, two colossal slabs of Earth's crust that have been colliding and grinding against each other beneath the continent. This slow-motion battle has been shaping the landscape for eons, giving rise to the Andes Mountains and fueling the region's numerous volcanoes. However, recent studies suggest that this long-standing equilibrium may be breaking down. Seismometers stationed across the continent have detected a sharp increase in deep tremors, tiny, barely perceptible earthquakes that indicate movement far below the surface. What's strange is that these tremors are not typical of standard tectonic plate activity. Instead of occurring along predictable fault lines, they are appearing in random clusters, often in places where earthquakes are rarely recorded. This suggests that something unusual is happening underground, possibly the formation of a hidden rift that is causing the continent to stretch apart. Some geologists believe that an ancient, dormant fault line buried beneath South America may have been reactivated due to shifting pressures within the mantle. This fault, which could date back millions of years, may have remained inactive for centuries until recent changes in the planet's internal heat flow disturbed its fragile balance. If this theory is correct, then the crack forming across the continent isn't just the result of gradual tectonic activity. It could be the beginning of a large-scale continental breakup event. There are historical precedents for such an event, most notably the East African Rift, where the African continent is slowly being torn in two. There The gradual separation of tectonic plates has already created massive fissures in the landscape, with some areas experiencing significant land collapses. In some parts of Kenya, the ground has split so dramatically that entire roads and villages have been swallowed overnight. Scientists fear that a similar process may be occurring in South America, only at a much faster and more chaotic rate. One of the more unsettling discoveries in recent months has been the detection of unusual heat signatures deep below the crack. Thermal imaging satellites operated by NASA have picked up strange fluctuations in temperature, indicating that magma might be rising toward the surface. Normally, volcanic activity is associated with well-known hotspots, but in this case, the heat appears to be diffused across a broad region. If this hidden magma chamber continues to expand, it could act as a wedge, forcing the land to split apart even further. Another critical factor is the changing stress distribution along the South American plate. The Amazon basin, one of the world's largest lowland regions, sits directly east of the crack and exerts immense pressure on the underlying crust. The sheer weight of the rainforest, combined with the massive river systems running through it, may be causing the crust to flex in unpredictable ways. Some researchers believe that a process known as isostatic rebound could be at play, where land that was once compressed under great weight suddenly begins to lift as conditions change. If portions of the crust are rising while others are sinking, it could be exacerbating the split and increasing the risk of large-scale structural collapse. Even more concerning is the potential role of deep underground reservoirs shifting due to the changes in pressure. South America is home to some of the world's largest aquifers, vast underground lakes that have existed for thousands of years. If these water reserves are being displaced or drained due to geological movements, it could lead to massive sinkholes, further destabilizing the land above. Some experts speculate that the sudden collapse of ground in certain areas, where entire forests have been swallowed overnight, could be linked to these underground shifts. What makes this situation so difficult to predict is that there is no single cause. Instead, it appears to be the result of multiple factors converging at once: tectonic forces, mantle heat, water displacement, and shifting stress patterns. Each of these elements alone might not be enough to create such a drastic transformation, but together, they are forming a perfect storm of geological upheaval. For now, scientists remain divided on what will happen next. Some believe the crack may stabilize over time, while others fear it could lead to an event that permanently alters the continent. Regardless of the outcome, one thing is certain: South America is changing before our eyes, and humanity can do little more than watch as the Earth reshapes itself in ways we are only beginning to understand. One of the most unsettling aspects of this developing crack is the eerie unpredictability of its expansion. While many tectonic processes unfold at a steady, almost imperceptible rate over millions of years, this fissure seems to be accelerating at an alarming pace. Some satellite images taken just months apart show drastic shifts in the landscape, with the crack widening at rates that defy conventional geological models. This inconsistency has left scientists scrambling for answers, raising urgent questions about whether human activity or unforeseen natural forces could be playing a role in hastening the split. One particularly troubling hypothesis suggests that deep within the Earth's crust, an ancient tectonic scar, possibly a remnant from when South America first broke away from Africa millions of years ago, may have been lying dormant, only to be reactivated by a chain reaction of environmental and geological shifts. This theory is supported by the odd pattern of seismic activity detected along the crack. Normally, when a fault line moves, it does so in predictable, linear patterns. But the tremors occurring near this fracture zone don't follow the expected trajectory of known fault systems. Instead, they seem scattered, as if the entire region is experiencing stress in a chaotic, unstable manner. Adding to the mystery is the behavior of certain deep underground rock formations. Scientists studying seismic waves traveling through the affected areas have noticed irregularities that suggest pockets of weaker rock are collapsing under intense pressure. These collapses could be acting as silent triggers, destabilizing the region from the inside out. When rock formations suddenly shift or dissolve, they create voids beneath the surface, essentially creating an underground domino effect. One section weakens, triggering instability in surrounding regions, which then leads to further collapses and widening cracks on the surface. The idea that South America's crack could be fueled by these subterranean instabilities is further supported by strange occurrences in the region. Local residents living near the fissure have reported hearing deep, guttural rumblings, low-frequency vibrations that seem to come from beneath the earth. These sounds are difficult to detect with standard equipment, but specialized geophysical sensors have picked them up, and their signature is unlike anything previously recorded in the area. In other parts of the world, similar phenomena have preceded significant seismic shifts or even volcanic eruptions. Could these deep, unexplained sounds be the Earth's way of warning us about an impending catastrophe? Some researchers are now turning their attention to the role of mantle plumes, massive upwellings of superheated rock that rise from deep within the Earth, much like a bubble in boiling water. These plumes are responsible for creating volcanic hotspots, such as the one beneath Yellowstone, but in South America, something different may be happening. If a new mantle plume were emerging beneath the continent, it could be exerting extreme upward pressure, causing the lithosphere to stretch and crack apart. In simpler terms, the continent itself could be undergoing a slow-motion tearing effect from deep within. If this is the case, the implications could be far-reaching. Such mantle-driven geological changes are thought to have played a role in the breakup of ancient supercontinents like Pangaea. In those cases, what began as minor fissures eventually widened into vast ocean basins, splitting landmasses permanently. Could South America be experiencing the early stages of such a process? If so, then we are not just witnessing a localized fracture but the beginning of a transformation that could reshape the continent entirely. What makes this situation even more complex is the role of water. We often think of the Earth's crust as a solid, unyielding mass, but in reality, it is riddled with underground reservoirs and water pathways that act as lubricants for tectonic movement. Some geologists suspect that shifting groundwater reserves might be worsening the situation, allowing the crack to spread more easily than it otherwise would. In some locations, newly formed sinkholes have been observed appearing near the fissure, suggesting that underground caverns are collapsing as water levels change. This could indicate that the very fabric of the land is softening, making it more vulnerable to further splitting. Then there is the issue of climate change and its unexpected interactions with geological processes. Some scientists propose that the rapid melting of South America's glaciers, particularly in the Andes, could be redistributing weight across the continent, subtly altering the balance of forces that hold the land together. In other parts of the world, the sudden loss of ice mass has been linked to increased seismic activity. Could the melting of South America's ice fields be triggering a similar effect, contributing to the unexpected acceleration of the crack? If so, this would mean that what we are witnessing is not just a geological anomaly but part of a larger, interconnected system of planetary changes. All of these factors, the possibility of an ancient tectonic scar reactivating, the chaotic stress distribution in the crust, the strange underground vibrations, the suspected mantle plume activity, and the shifting of groundwater and ice, paint a picture of a region that is experiencing a complex and highly unusual geological transformation. Scientists are only beginning to piece together the full extent of what is happening, but one thing is clear: this is not a normal, run-of-the-mill tectonic event. Something much larger is unfolding beneath our feet. This uncertainty is exactly what has alarmed experts worldwide. Geologists, seismologists, and geophysicists have been flocking to the region, setting up new monitoring stations, deploying drones, and using advanced imaging techniques to get a clearer picture of what is going on. Despite their efforts, the data remains perplexing. Some readings suggest that the crack is expanding at an accelerating pace, while others indicate periods of sudden, unpredictable movement. Unlike traditional fault lines, which move in relatively steady and well-understood ways, this fracture behaves erratically, almost as if responding to some unseen force that scientists have yet to identify. The biggest question now is, how much worse can this get? If the fissure continues to widen at its current rate, will we see dramatic changes in South America's geography within our lifetime? Could this split eventually form a new inland sea, much like the Red Sea did when Africa and Arabia drifted apart? Or is this merely a temporary shift, a phase that will stabilize over time? No one can say for certain. Normally, tectonic movements follow well-documented trends, where stress builds along fault lines and eventually releases in a seismic event. But what's happening here defies standard expectations. Instead of progressing in a steady, measurable manner, the crack seems to be accelerating sporadically, sometimes expanding by mere millimeters over weeks and then suddenly widening by several meters overnight. This irregularity suggests that multiple forces are at play, some of which may be beyond our current understanding of plate tectonics. One possible explanation lies in the complex network of microfaults beneath the surface. These hidden fractures, invisible to the naked eye, act as weak points in the crust. If these microfaults are interwoven in an intricate, unstable pattern, they could be contributing to the erratic growth of the crack. Unlike major fault lines, which absorb and distribute stress in a predictable way, microfaults can behave like a house of cards. When one shifts, it can trigger a chain reaction, causing abrupt and uneven movement across the region. Some researchers speculate that the South American fissure may not be a singular split, but rather the outward symptom of a much deeper and widespread structural failure within the continent's crust. Supporting this theory are recent GPS readings showing that different sections of the crack are moving at different rates. This is unusual because, in a typical tectonic event, the entire affected area moves in unison. But here, some sections are advancing more rapidly than others, almost as if parts of the landmass are sinking while others are pulling apart. This irregular motion has led some scientists to believe that what we are witnessing isn't just a surface-level fracture. It could be the early stages of a much larger-scale rifting process, one that might eventually reshape South America's geography in ways we cannot yet predict. Adding another layer of complexity to this puzzle is the presence of newly forming underground voids. Seismic imaging has detected empty pockets beneath the surface in areas where the crack is widening the fastest. These cavities, some of which are hundreds of meters wide, seem to be forming as underground material shifts and erodes. This suggests that the split may not just be a function of tectonic movement, but also of subterranean collapses caused by changes in underground pressure and composition. One possible culprit behind these collapses is the migration of deep, pressurized fluids. Below the Earth's surface, vast networks of mineral-rich waters flow through porous rock, often interacting with volcanic systems. If something has altered the balance of these underground reservoirs, such as a sudden temperature shift or a redirection of flow, then it could be causing unexpected structural weakening. Some scientists theorize that as these deep fluids shift, they may be dissolving certain types of rock, leading to subsurface voids that then collapse, causing sudden and dramatic widening of the fissure. This would explain why some areas are experiencing dramatic overnight expansion. If the crack were merely a surface-level fracture, it would likely spread at a more gradual pace. But if it's being driven by the collapse of underground chambers, then its unpredictable behavior starts to make more sense. These collapses could be occurring in stages, with certain areas suddenly giving way while others remain stable for a time before following suit. This could be why satellite imagery has captured moments where the fissure expands abruptly, seemingly without warning. There is also the unsettling possibility that what we are seeing is the result of deep-seated mantle movements. Some models suggest that a section of the South American lithosphere, essentially the rigid outer shell of the Earth, might be detaching and sinking into the mantle at an accelerated rate. This process, known as lithospheric delamination, occurs when a portion of the tectonic plate weakens to the point that it separates and drops into the hotter, more fluid layer beneath. When this happens, the overlying crust can stretch and thin, leading to dramatic surface fractures. If lithospheric delamination is at play here, then the South American crack could be a warning sign of an even greater transformation happening beneath the continent. As the lower portion of the plate sinks, the land above it could begin to stretch apart more rapidly, further widening the fissure. In some cases, this process has been linked to the early stages of continent splitting, where rifting eventually gives way to the formation of an entirely new ocean basin. Could South America be on the path to experiencing such a drastic change? While this idea might sound extreme, history provides us with compelling parallels. The East African Rift, for example, is a massive continental tear that is slowly splitting Africa apart. Over millions of years, what started as a series of small fissures has evolved into a vast rift system, with sections of land moving away from each other at measurable rates. In some places, the rift has already begun forming new bodies of water, marking the early stages of what could one day become a new ocean. What's alarming about the South American crack is that its rate of change seems to be faster than what we've observed in similar geological processes elsewhere. If this acceleration continues unchecked, then we may not be looking at a slow, gradual continental shift, but rather a more abrupt transformation. This raises urgent questions about what the near future holds. Could this fissure give way to massive earthquakes as the surrounding land adjusts? Will we start to see entire sections of the continent shifting apart in our lifetimes? Could the formation of an inland sea be closer than we think? Perhaps the most unsettling aspect of all of this is the lack of precedent. While rifting events have occurred throughout Earth's history, they typically happen over spans of tens of millions of years. The idea that a continental crack could expand rapidly within human timescales is something that geologists are struggling to grapple with. If the South American fissure continues to behave in such an unpredictable manner, it may force us to reconsider many of our assumptions about how continents evolve and change. One of the most unsettling theories emerging from recent investigations is the possibility that the crack is being influenced by deep-seated magma movements beneath the continent. While South America is no stranger to volcanic activity, boasting some of the most active and dangerous volcanoes in the world, what's happening here seems to be something different. Unlike typical volcanic rift zones, where magma steadily rises to the surface, this anomaly appears to be the result of a vast underground reservoir of molten rock that is shifting unpredictably beneath the continent's crust. Geologists analyzing seismic data have detected unusual tremors that don't match the typical patterns of earthquakes caused by fault movement. Instead, these tremors resemble what's known as harmonic tremors, which are commonly associated with magma movement deep underground. In a normal volcanic event, such tremors would suggest that magma is rising toward the surface, potentially indicating an impending eruption. But here's where things take a strange turn. These tremors aren't localized around a single volcano. Instead, they are occurring along the entire length of the fissure, suggesting that a massive subsurface system of magma is shifting beneath South America's crust on a continental scale. To put this into perspective, imagine an enormous underground river of molten rock stretching beneath the continent, subtly pushing against the lithosphere from below. If this magma chamber is expanding, it could be exerting pressure on the crust, forcing it to crack apart in ways that don't align with traditional plate tectonics. In other words, the South American fissure might not be a typical tectonic rift at all. It could be the surface-level expression of an immense and growing magmatic intrusion that is changing the very structure of the continent from within. A historical comparison that might shed light on this phenomenon is the African Rift System, which extends from the Red Sea down through East Africa. In that region, massive magmatic intrusions have been detected beneath the Rift Valley, contributing to the slow separation of the African continent. In some places, these underground magma movements have already resulted in the formation of new lakes and valleys. If something similar is occurring in South America, then the crack we're seeing today could be just the beginning of a much larger, long-term transformation. But what makes this situation even more unnerving is the possibility that this magmatic activity could trigger unexpected volcanic eruptions in regions that have been geologically stable for thousands of years. South America already has a history of explosive volcanic activity, particularly along the Andean volcanic belt, where the famous stratovolcanoes of Chile, Peru, and Ecuador stand. But if magma is truly shifting beneath the fissure, then it might be reactivating long-dormant volcanic systems, or even creating entirely new ones. Seismic imaging has already identified areas along the crack where underground heat signatures are intensifying, a strong indication that molten rock is moving closer to the surface. Some of these heat anomalies are appearing in places with no known volcanic history, which suggests that entirely new magmatic pathways are forming. If this continues unchecked, we could start to see unexpected geothermal activity, such as hot springs suddenly emerging where none existed before, or even violent steam-driven eruptions known as phreatic explosions. One of the most concerning aspects of this scenario is that if magma is involved in driving this fissure, then South America might not just be splitting. It could be priming itself for a series of volcanic events that could reshape the entire landscape. In the worst-case scenario, this could lead to the creation of a new volcanic plateau, where widespread fissure eruptions blanket the land in lava, similar to what happened during the formation of the Deccan Traps in India millions of years ago. Another real-world example that offers a possible parallel is Iceland's rift zones, where magma has played a significant role in the island's expansion. There, large cracks in the Earth's surface are not just passive fault lines but active conduits for magma, constantly reshaping the landscape with lava flows and new volcanic vents. Could South America be experiencing an early-stage version of this on a far larger scale? If so, this could have dire consequences for the millions of people living in the affected regions. Volcanic gases such as sulfur dioxide could be released in massive quantities, leading to air quality hazards and acid rain that could devastate agriculture. Ground deformation could accelerate, leading to land subsidence and the displacement of entire communities. Even worse, if the crack eventually serves as a pathway for a full-scale magmatic event, it could give rise to eruptions on a scale South America has never seen before. What makes this situation all the more puzzling is that there is no clear source for this magmatic intrusion. Unlike conventional volcanic systems that are fed by hotspots or subduction zones, this one appears to be operating independently of known geological boundaries. Some researchers have even speculated that South America might be sitting atop an unknown mantle plume, an upwelling of extremely hot rock rising from deep within the Earth. If this is the case, then the continent might be undergoing a geologic awakening that could permanently alter its shape over the coming millennia. Yet despite the mounting evidence, there are still more questions than answers. Why is this happening now? Could climate change or the melting of ice caps be playing a role in altering the pressure balance beneath the Earth's surface? Some scientists believe that the redistribution of weight due to melting glaciers and rising sea levels could be subtly affecting magma flow in ways we don't yet fully understand. Others argue that we may simply be witnessing the continuation of a process that began millions of years ago, one that has only now reached the point of becoming visible on the surface. For now, researchers are scrambling to install additional monitoring stations along the fissure, hoping to catch any signs of increased volcanic activity before it's too late. The world will be watching closely, as this unfolding mystery has the potential to redefine what we thought we knew about continental dynamics. If South America truly is splitting apart due to deep-seated magma movements, then we are witnessing history in the making, a slow-motion disaster that could reshape an entire continent before our very eyes. If the underground magma movement is truly responsible for South America's growing fissure, then its long-term consequences could be even more dramatic than we currently realize. While the surface changes appear slow on a human timescale, beneath the Earth, things could be progressing at a much more volatile pace. Magma doesn't just passively shift underground, it exerts immense pressure on the surrounding rock, warping the crust in ways that can be unpredictable and sometimes catastrophic. The fact that harmonic tremors are being detected along the fissure means that molten rock isn't just sitting idle. It's actively pushing, breaking through, and reshaping the terrain beneath South America in ways that we can't fully see yet. One of the biggest concerns is that this increasing magmatic pressure could eventually trigger an outright rupture of the surface. In volcanic systems, this process often leads to the creation of new fissure eruptions, where lava suddenly begins to spew from the ground, not from a traditional conical volcano, but from long, deep cracks in the earth. These kinds of eruptions are especially dangerous because they don't come with the usual warning signs that volcanologists look for. There's no swelling of a central volcano, no obvious buildup of pressure inside a single magma chamber. Instead, the land simply tears open, releasing molten rock in an unpredictable and often uncontrollable fashion. A haunting example of this occurred in Iceland in 1783, when the Loki fissure eruption produced one of the largest lava flows in recorded history. Over 8 months, the eruption spewed out an unimaginable amount of lava, more than 14 cubic kilometers, blanketing the land and releasing toxic gases that led to widespread famine. If a similar event were to occur in South America along the developing crack, the devastation could be on an even greater scale. The region around the fissure is densely populated, with major cities, farmland, and infrastructure standing directly in harm's way. If the land splits open and magma breaches the surface, there could be little warning before entire regions are engulfed. Complicating the matter even further is the possibility that this magmatic pressure is not only causing the fissure to grow, but is also weakening the stability of the surrounding crust. If the ground becomes too compromised, it could lead to sudden collapses, sinkholes, and even massive fault slip events that trigger devastating earthquakes. Unlike tectonic quakes, which occur due to the slow buildup of stress between plates, magmatic earthquakes can happen more erratically, as the movement of molten rock redistributes stress in unexpected ways. The unpredictability of this process makes it nearly impossible to forecast exactly when or where the next major event could strike. In some cases, magma-driven rifting can lead to the creation of entirely new bodies of water. In 2005, an enormous 60-kilometer-long rift opened up in Ethiopia's Afar Desert almost overnight. What was once a solid stretch of land suddenly cracked apart, and scientists soon realized that it was the beginning of a new ocean basin forming right in front of their eyes. If the South American fissure continues to widen and deepen, it's not impossible to imagine a similar fate, an entirely new inland sea forming in the heart of the continent as water from surrounding rivers and rainfall begin to fill the depression. Over thousands of years, this could lead to a complete transformation of the geography, cutting the landmass in two and giving birth to a new seaway. But perhaps the most alarming possibility is the idea that South America is sitting on top of an undiscovered supervolcanic system, one that has remained dormant for tens of thousands of years, but is now slowly awakening. Supervolcanoes are among the most dangerous natural phenomena on Earth, capable of producing eruptions that can plunge the planet into a volcanic winter, blocking out sunlight and triggering widespread famine. While most known supervolcanoes, such as Yellowstone in the United States or Toba in Indonesia, have been extensively studied, there is still much we don't know about the hidden magmatic systems lurking beneath the continents. Some experts believe that the Andean region, particularly beneath Bolivia and Argentina, may conceal a vast and largely unexplored magmatic province, one that could be far larger than previously thought. If the crack is somehow connected to a deeper, ancient magma reservoir, then what we're seeing might not just be surface-level rifting, it could be the first warning sign of a colossal geological event in the making. One piece of evidence that supports this theory is the presence of vast ignimbrite deposits found across the Andean region. These thick layers of volcanic rock are the remnants of past supereruptions, suggesting that in ancient times, massive explosions reshaped the continent in ways we are only beginning to understand. If the fissure is somehow linked to the reactivation of such a system, then the stakes are far higher than anyone previously imagined. Even now, satellite data is picking up signs that the land around the fissure is experiencing unusual inflation, an indication that something is pushing up from below. This uplift is eerily similar to what has been observed in places like Yellowstone, where magma slowly accumulates beneath the crust, stretching the land like a balloon before an eruption. While no one can say for certain whether an eruption is imminent, the fact that such activity is occurring at all suggests that the forces at work beneath South America are far from normal. If scientists can confirm that this fissure is linked to a deep-seated magmatic process, it could change everything we thought we knew about South America's geologic future. The continent might not just be splitting, it could be entering an era of renewed volcanic activity, one that could reshape entire landscapes, displace millions of people, and alter the global climate if a large enough eruption were to occur. One of the most perplexing aspects of this phenomenon is the sheer unpredictability of magma migration. Unlike tectonic plate movement, which follows slow, measurable patterns, magma can shift in ways that defy conventional geological expectations. It can pool in deep chambers for thousands of years, remaining relatively stable, only to suddenly surge upward in a matter of weeks or even days. There is evidence that beneath parts of Bolivia and northern Argentina, massive reservoirs of semi-molten rock exist, largely undisturbed for millennia. Some geologists now believe that these reservoirs may be slowly destabilizing, feeding heat and pressure into the crack that is splitting South America apart. One particularly alarming possibility is the formation of a large-scale rift volcano, a phenomenon rarely seen on Earth outside of places like Iceland or the East African Rift Valley. Rift volcanism occurs when magma forces its way upward along a spreading fault line, creating vast fissures in the crust that erupt not from a single cone-shaped volcano but from long, gaping wounds in the Earth itself. These eruptions can last for years, spewing lava in enormous quantities and permanently altering the landscape. To understand how catastrophic this could be, we only need to look at the Laki eruption of 1783 in Iceland. Over an 8-month period, lava continuously erupted from fissures in the ground, covering vast areas and molten rock. But the worst effects weren't just the lava flows themselves. The eruption released immense amounts of toxic sulfur dioxide into the atmosphere, which spread across Europe, blocking sunlight and lowering temperatures. This caused massive crop failures, leading to food shortages and starvation. Historical records suggest that over 6 million people across Europe may have perished due to the climatic effects of the Laki eruption. If a similar event were to occur in South America's growing fissure zone, the consequences could be just as devastating, if not worse. South America, with its dense population centers and vast agricultural regions, is particularly vulnerable to this kind of disaster. The Amazon basin, which plays a critical role in stabilizing the global climate, is already under environmental stress, and the introduction of large-scale volcanic activity could push it past the tipping point. If sulfurous gases were to blanket the continent, they could mix with moisture in the air, creating acid rain that would devastate crops, poison water supplies, and accelerate deforestation. The climate effects could ripple across the entire world, triggering temperature drops and extreme weather patterns in ways we might not be able to predict. Some scientists are beginning to wonder if the increased volcanic and seismic activity in the region could be linked to an even greater, more ancient process, one that goes beyond South America itself. There is a theory that every so often, the deep mantle of the Earth undergoes shifts that set off chains of events across multiple continents. Known as superplume events, these shifts involve the upwelling of massive amounts of molten material from deep within the planet, driving not just local volcanic activity, but global geological transformations. In 2017, researchers studying seismic waves beneath South America detected what appeared to be an unusually large and persistent thermal anomaly in the mantle. This hot spot was unlike anything seen before, an upwelling of superheated rock that extended far deeper than most known magma plumes. Some experts theorize that this anomaly might be part of a much larger system, one that could be directly linked to the increased magmatic activity near the fissure. If true, this would mean that South America's continental rift isn't just an isolated event, it's part of a much grander and more complex planetary process, one that could be decades or even centuries in the making. What makes this possibility even more concerning is that it aligns with patterns observed in Earth's past. Geological records indicate that roughly every 30 to 50 million years, vast shifts in the mantle lead to increased volcanism, massive rifting, and even the breakup of entire land masses. Some of the largest extinction events in history, including the Permian-Triassic extinction, have been linked to these kinds of deep Earth processes. Could it be that we are entering another such era? Could the splitting of South America be the first warning sign that our planet is undergoing one of its most significant transformations in millions of years? While it's impossible to say with certainty, what is clear is that the fissure is continuing to grow, and the forces beneath it are still poorly understood. Satellite data has shown that parts of the continent are subtly rising, as if being pushed upward from below, while other areas are sinking. This kind of movement suggests that enormous pressures are at work, pressures that could, at any moment, lead to a catastrophic rupture. The question now is not just whether South America is splitting, but how fast, and what the long-term consequences will be. There is another theory gaining traction among scientists, one that ties the growing fissure in South America to an ancient and long-forgotten force deep within the Earth. This idea suggests that the continent is being slowly torn apart by the resurgence of an ancient, buried tectonic plate, one that was thought to have disappeared millions of years ago but may now be reawakening. If true, it would mean that what we are witnessing is not just a surface-level rift, but the resurgence of a hidden force that has been dormant for millennia. To understand how this could be possible, we must first look at the concept of subducted plates. Earth's lithosphere, the rigid outer shell of the planet, is broken into massive pieces called tectonic plates, which slowly move over geological timescales. Some plates collide, forcing one beneath the other in a process known as subduction. Over time, these sunken plates sink deep into the mantle, where they are gradually consumed by the intense heat and pressure. At least, that is what we once believed. Recent advances in seismic imaging, however, have revealed that some of these plates may not be fully destroyed. Instead, they may sink into the lower mantle and remain there for millions, or even hundreds of millions, of years, barely moving, almost as if they are trapped in a kind of geological limbo. But sometimes, something changes. A shift in mantle dynamics, an increase in temperature, or even a long, slow buildup of stress could trigger one of these ancient plates to begin rising again. When that happens, the results can be catastrophic. In 2016, geologists discovered what they believed to be a vast, deeply buried tectonic structure beneath South America, known as the Phoenix Slab. This ancient remnant of oceanic crust is thought to have once been part of the Nazca Plate, which subducted beneath the continent millions of years ago. For a long time, it was assumed that this buried plate was inactive, slowly sinking and breaking apart into the deeper layers of the Earth. But new data suggests otherwise. Recent seismic readings indicate that instead of sinking, parts of the Phoenix Slab may be rising back toward the surface, pushed upward by intense mantle currents beneath the continent. If this is true, then the implications are staggering. It would mean that an entire section of ancient oceanic crust is pressing upward against South America's lithosphere, creating immense stress along fault lines and forcing the land above it to crack and separate. There are some eerie precedents for this kind of activity. In the 1990s, researchers studying the history of the North American continent discovered evidence that a similar phenomenon had occurred in the past. About 100 million years ago, a now-vanished plate called the Farallon Plate began to subduct beneath what is now the western United States. But instead of simply disappearing into the mantle, parts of it remained trapped, slowly pushing up against the bottom of the continent. This hidden force was responsible for much of the uplift that created the Rocky Mountains. Some experts believe that what is happening in South America right now could be a mirror of that ancient event, except on a potentially more violent scale. One of the most alarming aspects of this possibility is how unpredictable it makes the growing fissure. If the crack were simply caused by normal rifting, geologists could estimate how fast it might expand or what regions would be affected next. But if the movement of an ancient, buried plate is at play, the shifts in the ground could be sudden, erratic, and completely outside of our current understanding. Instead of a slow, gradual separation, we could be looking at the potential for sudden, massive ruptures, breaks in the land that could happen unexpectedly, splitting cities apart in an instant. This might explain some of the more unusual seismic activity seen near the fissure. Instead of the typical patterns of earthquake swarms that accompany most rift formations, scientists have detected deep, long-duration tremors that seem to originate from much farther beneath the surface than expected. These tremors bear a striking resemblance to those seen in subduction zones, regions where one tectonic plate is pressing against another. But South America's fissure is not near a traditional subduction zone. If these deep tremors really are being caused by the Phoenix Slab rising, it means that the entire structure of the continent is being rearranged in ways we have never seen before. This could also help explain why the landscape around the fissure has been deforming in unpredictable ways. In regions where the crack is most active, some areas have been rising, while others have been sinking. This is a hallmark of a hidden tectonic force at work. Something beneath the continent is actively pushing certain sections upward while pulling others downward. If the Phoenix Slab is truly reactivating, we may be witnessing the earliest stages of an event that could completely reshape South America as we know it. Perhaps the most unsettling aspect of this theory is that we have no real way to predict what will happen next. The forces at play are operating on scales far larger and deeper than anything humanity has ever directly observed. The best we can do is look at past geological events and try to infer what might come next. But if this buried plate is indeed making a comeback, then the crack splitting South America could be just the beginning of something far larger, something that could take centuries to unfold, or could accelerate suddenly, without warning. This possibility raises urgent questions. If this phenomenon continues, will South America eventually split apart completely? Will the Phoenix slab continue pushing upward, triggering more fractures, earthquakes, and volcanic activity? Or is this just the first sign of an even larger, more catastrophic process beginning beneath our feet? Whatever the case, the mystery deepens. The growing fissure in South America is not just a crack in the ground, it is a doorway into the unknown, a glimpse into the hidden forces that shape our planet in ways we are only beginning to understand. If the Phoenix slab is truly reawakening beneath South America, it could be influencing the entire tectonic framework of the continent in ways that go far beyond just the visible cracks splitting the land. One of the most concerning possibilities is the interaction between this ancient plate and the massive, deeply buried faults that run beneath the continent, some of which have been locked in place for millions of years. If these faults begin to slip as a result of pressure from below, it could trigger seismic events of unprecedented magnitude. To understand the scale of this danger, we have to consider the nature of ancient faults and how they behave over long periods of time. Faults are essentially fractures in the Earth's crust where two sections of rock can move relative to each other. Some faults are highly active, constantly shifting and causing earthquakes. Others, however, remain locked for thousands, or even millions, of years, held in place by the immense friction of the surrounding rock. These dormant faults are especially dangerous because, over time, stress builds up along them. The longer they remain locked, the more energy accumulates, waiting for a trigger to set it loose. There are numerous examples in history where seemingly inactive faults have suddenly sprung to life, causing devastation on an unimaginable scale. One of the most infamous cases is the 2011 Tohoku earthquake in Japan. Before the disaster, scientists knew that stress was building along the fault, but they underestimated how much energy had accumulated over centuries of inactivity. When the fault finally slipped, it unleashed a magnitude 9.1 earthquake, shifting the entire island of Honshu several meters and triggering a deadly tsunami. If a similar event were to occur in South America as a result of the shifting Phoenix slab, the consequences could be catastrophic. One fault system that has experts particularly concerned is the massive Peruchili megathrust, which runs along the western edge of South America, where the Nazca Plate is subducting beneath the continent. This fault has produced some of the most powerful earthquakes in recorded history, including the devastating 1960 Valdivia earthquake, the largest earthquake ever recorded, measuring a staggering magnitude 9.5. But what if the forces beneath the continent are shifting in ways we have never seen before? If the reawakening of the Phoenix slab is exerting new pressures on this fault system, it could destabilize large sections of the megathrust, setting off a domino effect of seismic activity stretching for thousands of kilometers. More troubling still is the presence of lesser-known faults buried deep beneath the interior of the continent, faults that have not moved in recorded history but may be primed for sudden activation. Some of these faults date back to the very formation of South America as a landmass, remnants of ancient tectonic collisions from hundreds of millions of years ago. If the rising slab below begins exerting force on these long-dormant structures, they could rupture violently and unpredictably. One particularly concerning region is the Amazon basin, an area not typically associated with large earthquakes. However, recent seismic scans have suggested the presence of deeply buried fault lines beneath the basin that have been inactive for eons. If new tectonic stress is being introduced from below, it is entirely possible that these ancient faults could awaken in a sudden and catastrophic event. Unlike the well-monitored megathrust faults along the coast, these interior faults are largely unstudied, meaning any earthquake they generate could take the world by complete surprise. Beyond the risk of earthquakes, the shifting forces beneath South America could also have profound effects on the region's volcanic activity. The Andes Mountains are home to some of the most active and dangerous volcanoes in the world, many of which are directly tied to the ongoing subduction of the Nazca Plate beneath the continent. If the movement of the Phoenix slab is altering the flow of magma beneath the surface, it could destabilize these volcanic systems in ways we have never witnessed before. One volcano that has scientists especially worried is Uturincu, a massive stratovolcano in Bolivia. Over the past few decades, satellite data has revealed that the ground around Uturincu has been steadily rising, a sign that magma is accumulating beneath the volcano. Some researchers believe that this uplift could be connected to deep changes in the subduction system beneath South America. If the reactivation of the Phoenix slab is further increasing magmatic pressure beneath the Andes, it could push Uturincu, and many other volcanoes, toward a full-scale eruption. The potential for increased volcanic activity extends beyond just the Andes. Further east, deep beneath the Amazon rainforest, lies a little-known but highly intriguing geological feature known as the Rio Negro Igneous Province. This ancient volcanic system, long thought to be extinct, consists of massive underground magma reservoirs buried beneath the jungle. Some experts have speculated that shifts in the deeper mantle could theoretically reactivate this system, leading to new volcanic eruptions in a part of the world that has not seen such activity for millions of years. This possibility, while highly speculative, raises an unsettling question: are we witnessing the early stages of a tectonic reorganization that could permanently reshape South America? If so, what would that mean for the future of the continent? Would entire regions become uninhabitable due to constant earthquakes and volcanic eruptions? Would South America eventually split apart completely, creating an entirely new ocean in the middle of the continent? Another possible cause for the cracks splitting South America could be linked to human-induced activities, specifically the large-scale extraction of natural resources. While Earth's geological processes are typically driven by natural forces, there's a growing body of evidence suggesting that human activities, such as mining, oil drilling, and groundwater extraction, can have significant impacts on tectonic stability. The idea that human activity can trigger seismic events or even contribute to the shifting of tectonic plates is still relatively new, but it's becoming increasingly difficult to ignore the correlation between certain resource extraction methods and increased seismic activity. Take, for instance, the case of the Permian Basin in the United States. In 2018, researchers began noticing a marked uptick in seismic activity in this region, which had traditionally been considered stable. Upon further investigation, it became clear that the increased number of earthquakes was linked directly to oil and gas extraction. Specifically, the disposal of wastewater, left over from the oil drilling process, into deep wells was exerting pressure on underground fault lines, effectively triggering earthquakes. This process, known as induced seismicity, occurs when human activities introduce new forces into the Earth's crust, causing previously stable structures to shift. While these earthquakes are often small in magnitude, the sheer number of them has led researchers to reconsider the impact that such resource extraction methods can have on regional tectonics. This phenomenon has been documented in other parts of the world as well. In the Netherlands, for example, natural gas extraction has led to an increase in seismic activity, most notably in the town of Groningen. As gas is pumped from the ground, the pressure that once held the surrounding rock together decreases, leading to small but frequent tremors. In regions like these, the effects of resource extraction are not limited to the immediate area of drilling. They can reverberate across larger, often unexpected, regions. In the case of South America, the extensive mining operations throughout the continent could be putting similar pressure on fault lines, destabilizing areas that would otherwise be relatively unaffected. Of course, South America is no stranger to large-scale resource extraction. Countries like Chile and Brazil have some of the largest mining industries in the world, with copper, iron ore, and gold being extracted in massive quantities. Additionally, large oil reserves are found in places like Venezuela and Ecuador. Mining and drilling operations in these regions involve drilling into the earth at significant depths, a process that often alters underground pressure and can induce small shifts in the tectonic plates above. Over time, these shifts may accumulate and potentially lead to larger, more dangerous seismic events. In regions like the Andes Mountains, where seismic activity is already a concern due to the tectonic interactions between the Nazca and South American plates, the extraction of resources could be exacerbating existing stress points. Mining operations, especially those that involve the extraction of large amounts of minerals, often require extensive drilling and blasting. These processes can weaken the stability of nearby faults, or even create new fractures in the Earth's crust, which could ultimately contribute to the widening of the crack in South America. Additionally, the extraction of groundwater is another factor that has been linked to seismic events. In many parts of the world, especially in arid regions like northern Chile, groundwater is being pumped at unsustainable rates to support agriculture and mining operations. This overextraction can lead to the lowering of the water table, causing the ground above to collapse or sink. In extreme cases, this can trigger earthquakes or exacerbate existing geological instabilities. Though groundwater extraction may not directly cause the kind of tectonic shifts that create massive rifts like the one splitting South America, it can certainly add pressure to fault lines, making them more prone to activity. In South America, where many countries depend on the mining and extraction of resources for economic growth, the long-term effects of these practices may be reaching a critical point. Researchers and geologists are beginning to take a closer look at the ways in which these industries, combined with natural tectonic processes, could be contributing to the cracking of the continent. What makes this situation even more alarming is that many of these activities are happening in relatively remote or previously untouched regions, which means that the full scope of their impact may not be fully understood until a major seismic event occurs. The possibility that human activity is playing a role in the widening of the crack in South America underscores a much larger issue: our growing impact on the planet's geological systems. While the Earth's tectonic plates have been shifting for millions of years, the way in which we interact with the planet's surface can introduce new stresses and forces that may trigger events we don't fully understand yet. The crack in South America may not just be a natural occurrence. It could be a stark reminder of the unintended consequences of our exploitation of the Earth's resources. As we continue to extract resources from beneath the Earth's surface, the risk of destabilizing tectonic structures will likely grow. The challenge now is to determine whether the human footprint on the planet's geological systems is pushing us toward a larger-scale catastrophe. As scientists continue to investigate the cracks splitting South America, they will need to consider the potential impacts of resource extraction alongside the natural processes that have been shaping the continent for millions of years. Continuing on the topic of human-induced activity and its potential contribution to the cracking of South America, it's important to recognize that these large-scale resource extraction activities can have even more subtle, long-term effects on the environment. While the immediate impact of oil drilling, mining, or groundwater extraction is often seen in the form of localized environmental damage, the broader, more systemic consequences are sometimes harder to predict and often underestimated. One of the primary concerns lies in the cumulative effect of these activities over time. The sheer scale of resource extraction, particularly in South America, has been staggering. In places like the Amazon basin, large-scale mining operations have been linked to deforestation, soil erosion, and the contamination of water sources. But the environmental toll doesn't stop there. As these operations intensify, the pressure on the Earth's surface increases, potentially triggering seismic events that might otherwise not have occurred. A compelling example of this phenomenon can be found in the case of large hydropower dams. While South America is home to some of the world's most significant hydropower projects, such as Brazil's massive Belo Monte Dam, the construction and operation of these dams have been shown to alter the region's geological stability. These projects require the flooding of vast areas, which significantly changes the distribution of water and mass across the landscape. The weight of the water in these reservoirs, combined with the alterations in groundwater flow, can affect the stability of fault lines and contribute to seismic activity. Take the example of the Kariba Dam, located on the border between Zambia and Zimbabwe, which was constructed in the 1950s. After the completion of the dam, several small earthquakes were recorded in the region. Research indicated that the increased weight of the water in the dam reservoir, combined with the movement of groundwater, had contributed to a subtle but significant shift in the nearby fault lines. Although the tremors were not large enough to cause widespread destruction, they were enough to highlight how human infrastructure could inadvertently impact the Earth's crust. In South America, this same principle could be at play. Large-scale mining projects, such as the extraction of gold and copper in the Andes or the oil operations in Venezuela, could be exerting unseen pressure on the surrounding tectonic structures. These projects often involve the creation of massive pits and tunnels, as well as the diversion of rivers and streams to accommodate the flow of minerals and materials. All of these changes in the natural environment, while serving economic purposes, could be having unintended consequences on the geological stability of the region. Over time, the accumulation of such activities might be enough to contribute to the ongoing formation of the crack splitting South America. Another aspect to consider is the role of urbanization in these changing dynamics. As South America becomes increasingly urbanized, the development of large cities and the construction of infrastructure like roads, buildings, and bridges also introduces new forces into the Earth's crust. In rapidly growing cities like Lima, Peru, or Sao Paulo, Brazil, the construction of massive skyscrapers and infrastructure projects requires extensive excavation and foundation work. This process can disturb the ground, displace underground water sources, and even create localized shifts in the land that can have a ripple effect on nearby fault lines. While it may seem like these urban activities are too small to have any real effect on the larger geological processes at play, the cumulative impact of urbanization and resource extraction is becoming more apparent. In fact, some researchers have suggested that the widespread development of urban areas along fault zones may be increasing the risk of seismic events in regions that were previously considered stable. The role of groundwater extraction cannot be overstated in this equation. As we saw with examples like the Permian Basin in the US, excessive groundwater pumping can have destabilizing effects on the ground above it. In South America, particularly in countries like Argentina and Chile, the overextraction of groundwater for agriculture and industrial use has been a growing concern for decades. This depletion of groundwater resources can cause the ground to sink or shift, which can weaken fault lines and make them more susceptible to movement. In addition, the extraction of oil from deep reservoirs, especially in regions like the Amazon, can lead to the destabilization of surrounding rock layers. As oil is pumped out of the ground, the weight and pressure exerted on the surrounding geological formations change. This shift can alter the balance of forces in the Earth's crust and create a scenario where fault lines that were once dormant are awakened. The energy generated from these shifts could contribute to the rift that is splitting South America. As the region continues to deal with the environmental consequences of industrialization, the impact of these resource extraction methods on the Earth's crust cannot be ignored. The relationship between human activity and tectonic processes is not fully understood, but the evidence suggests that our actions are having a much larger effect than we previously thought. What makes this particularly concerning is that many of the areas most affected by these activities are located in regions where seismic events are already a risk. South America sits on the Pacific Ring of Fire, where tectonic plate interactions are most volatile. The impact of human activities on fault lines in this area, combined with the natural geological processes at play, could be contributing to the widening of the crack in South America. Ultimately, the continuing extraction of natural resources and the growth of urban infrastructure could be accelerating the process of tectonic movement in ways that are not immediately obvious. What we may be witnessing in South America is the result of a complex interplay between natural forces and human-induced changes to the landscape. If these trends continue, it may only be a matter of time before the effects become more pronounced and the consequences more severe. Shifting gears to another potential cause of the crack splitting South America, let's turn our attention to the role of climate change. While climate change is most commonly associated with rising sea levels, extreme weather events, and melting glaciers, it can also have significant, and sometimes overlooked, impacts on the Earth's geological systems. The connection between climate change and tectonic activity may not be immediately apparent, but a deeper look into the ways in which global warming alters the planet's surface reveals some fascinating and concerning links. One key aspect of climate change is its impact on the weight distribution of the Earth's surface. As glaciers melt due to rising temperatures, the weight that these glaciers once exerted on the land is gradually removed. This phenomenon is known as isostatic rebound. In regions that were once covered by thick ice sheets, the Earth's crust begins to slowly rise as it loses the immense pressure that the glaciers had placed on it. While this process is natural and occurs over thousands of years, the accelerating pace of ice melt driven by climate change could be causing it to happen more quickly, leading to unexpected shifts in the Earth's crust. In areas like Patagonia, in southern Argentina and Chile, the rapid melting of glaciers could be contributing to geological instability. These glaciers had once been massive, and their disappearance over recent decades could be creating stress within the Earth's crust. As the land begins to rebound and adjust to the loss of weight, previously stable fault lines and rock formations could be destabilized. This could explain, at least in part, the emergence of cracks and shifts in the landscape, as the Earth's crust attempts to adjust to the new weight distribution. Additionally, the increasing frequency and intensity of extreme weather events due to climate change can exacerbate geological instability. For example, the frequent flooding and erosion in coastal regions can weaken underlying rock formations, leading to landslides and other forms of land collapse. In places like northern Chile, where there has been a noticeable increase in extreme rainfall events, this erosion is accelerating, potentially compromising the stability of fault lines. Prolonged periods of drought, on the other hand, can cause the ground to dry out and shrink, which can create fissures and cracks in the surface. Over time, this can further destabilize the region, contributing to the widening of the crack in South America. Another fascinating aspect of climate change is its potential influence on underground water systems. The warming climate has led to changes in precipitation patterns, with some regions experiencing more intense rainfall while others face prolonged droughts. These shifts in water availability can alter the flow of groundwater beneath the Earth's surface. In some cases, an influx of water due to heavy rainfall or flooding can infiltrate underground fault lines, potentially lubricating them and making it easier for tectonic plates to shift. In other cases, the depletion of groundwater in regions facing drought could cause the ground to sink, again creating pressure points on fault lines and triggering seismic activity. This phenomenon isn't just speculative. It has been observed in other parts of the world. In California, for example, there has been an increase in seismic activity that some experts believe is linked to the prolonged droughts the state has faced over the past decade. As the groundwater levels have dropped, the land has shifted, making it more susceptible to fault movement. While the tectonic activity in California is largely attributed to the San Andreas Fault, similar processes could be at play in South America. Moreover, in the Andes, the region's highly active volcanic and seismic zones are subject to changes in pressure and temperature. As the climate warms, the increased volume of water from melting glaciers and snowpacks might alter the subterranean pressure that affects volcanic activity. Volcanic eruptions, while seemingly separate from tectonic shifts, can actually have an indirect effect on the movement of tectonic plates. The shifting of magma beneath the Earth's surface, combined with the changing pressures caused by a warming climate, could trigger seismic events or further contribute to the crack that is splitting South America. Another climate-related factor that may be contributing to this rift is the changing patterns of ocean currents. The warming of the oceans has led to an increase in the frequency of El Niño and La Niña events, which significantly alter weather patterns across South America. These changes can put additional stress on the land, with periods of extreme dryness followed by intense rainfall, leading to both surface erosion and the destabilization of subterranean structures. This irregular weather pattern could be increasing the pressure on fault lines, contributing to the shifting and expansion of the crack. Finally, it's essential to acknowledge the broader impact of rising sea levels on tectonic stability. As the ice caps melt and the oceans rise, the weight distribution of the Earth's surface changes in dramatic ways. The increased weight of water in some regions can add stress to the crust, potentially triggering faults to shift. In coastal areas of South America, this added weight could be a contributing factor to the ongoing geological shifts. The combination of rising seas and land movement could be accelerating the rate at which the crack in South America is widening. In essence, climate change is a multifaceted driver of geological instability in South America. The melting of glaciers, shifts in weather patterns, changes in underground water systems, and rising sea levels are all contributing to the pressures building up in the Earth's crust. These environmental shifts, driven by global warming, might not only be causing immediate changes in the landscape but could also set the stage for more significant geological events in the future. The relationship between climate change and tectonic movement is complex and still being studied, but there is growing evidence that the two are intricately linked. As the planet continues to warm, the ripple effects of climate change will likely continue to reshape the Earth's surface in ways we may not fully comprehend yet. Continuing with the link between climate change and the geological shifts occurring in South America, it's important to take a closer look at how the warming climate is affecting the region's seismic activity on a more localized scale. We've already touched on the broad effects of glacier melting, water systems, and atmospheric changes, but a deeper exploration into the role of soil moisture and temperature fluctuations might shed more light on how climate is impacting the stability of the ground itself. In regions such as the vast plains of Argentina and the Andean foothills, changes in soil moisture levels can be a critical factor in shaping the Earth's surface. Typically, these areas experience a delicate balance of wet and dry seasons, which maintain the stability of the ground. However, with increasing temperatures and erratic rainfall due to climate change, the moisture content in the soil is becoming increasingly unpredictable. When soil becomes too dry, it can shrink, creating fissures and cracks that could become a pathway for other forces, like water or even tectonic pressure, to enter. This can contribute to the gradual widening of cracks or rifts, adding to the strain already placed on the fault lines beneath the surface. On the flip side, during periods of intense rainfall or flooding, the ground can become overly saturated, which leads to its softening. As the weight of the water increases, the ground can experience significant compression. In extreme cases, this added weight combined with the natural subsurface forces may create pressure points that force fault lines to shift, particularly in the rift zones of South America. The movement of large amounts of water across the continent during storms can also create a destabilizing effect, especially in places where rivers swell rapidly and flood, like the Parana River in Brazil or the mighty Magdalena in Colombia. An interesting factor at play here is the changing pattern of atmospheric pressure, which directly impacts the way moisture is distributed across the continent. Changes in the jet stream and global wind patterns have made the rainy seasons in South America increasingly unpredictable. At times, areas experience prolonged periods of intense drought, followed by heavy rainfall and short bursts. This rapid fluctuation in soil moisture is particularly concerning in places like the Chaco region in Argentina and Bolivia, where the land is already subject to tectonic pressures from deep beneath the earth. As the moisture content swings dramatically from one extreme to the other, the ground responds by expanding and contracting, creating an environment where fault lines are more likely to be triggered. One of the most noticeable shifts in weather patterns is the increasing intensity of tropical storms and hurricanes, which have been exacerbated by global warming. In coastal regions of northern South America, such as Venezuela and Colombia, the effect of these storms is profound. The coastal plains, already a region where tectonic activity is more likely to occur, are now exposed to an even greater frequency of high winds and heavy rains. The repeated battering from these storms causes soil erosion along coastlines and riverbanks, weakening the stability of the land. In fact, there have been instances in which a powerful storm, combined with an unusually high tide, has been observed to cause small tremors along fault lines. While these tremors might not be strong enough to cause widespread damage, they can add additional strain to an already vulnerable region. Over time, this could create a cumulative effect, where multiple small shifts in the Earth's crust result in a more significant movement, like the opening of a crack or fissure. This is particularly concerning given the increase in storm intensity linked to climate change. The warming climate also accelerates the process of desertification in certain regions of South America, such as parts of the Atacama Desert in Chile and the Gran Chaco in Argentina. As the desert expands due to prolonged dry conditions, the region's soil and rock formations become more brittle and cracked. These expansive desert areas are often positioned along active tectonic zones, so when they start to dry out and crack, the effects can be felt deep within the Earth's structure. With desertification comes the possibility of new fault lines emerging, or existing ones becoming more pronounced. This change in the land's composition, driven by the effects of climate change, could be contributing to the widening rift. Another climate-related factor is the rising ocean temperatures that affect coastal areas, particularly in places like the southern tip of South America and the Andean coastal region. These areas are already vulnerable to tectonic movements due to their proximity to subduction zones, where the Nazca Plate is slowly being forced beneath the South American plate. However, as sea temperatures rise, the expansion of the oceanic crust becomes a contributing factor to the pressure placed on these tectonic zones. Oceanic expansion from warming water could subtly influence tectonic activity and contribute to shifting fault lines. This, in turn, could lead to the emergence or exacerbation of rifts like the one slowly splitting the continent. In some places, the increase in ocean temperatures and the resulting changes in sea level rise have also caused changes to the Earth's lithosphere. The cooling and warming of the ocean floor, along with the changes in water pressure, can lead to shifts in the Earth's surface. While it's not often something that's discussed in mainstream media, this gradual shifting of tectonic plates beneath the oceans could be influencing the region's geological stability. The weight of the water, coupled with the rising sea levels, can increase stress on the Earth's crust and make fault lines more likely to fracture. On top of all of this, let's not forget the psychological and practical toll that climate change is having on human populations. As more people migrate away from areas that are becoming uninhabitable due to droughts, floods, or extreme weather, the increased human presence in certain regions can also influence the land's stability. When large populations converge in specific areas, they bring with them infrastructure projects, industrial activity, and even urban expansion. These activities, combined with the pressures already placed on the land by climate change, can make fault lines more likely to experience movement. The added weight of human habitation, and the strain it puts on the Earth's crust, could be another contributing factor to the growing cracks splitting South America. The intersection of climate change and geological processes is not something most people think about when they consider the causes of tectonic movement. However, when you combine the accelerated effects of warming temperatures, sea level rise, erratic weather patterns, and soil changes, you begin to see how all of these factors can act as a catalyst for the geophysical shifts happening in South America. The consequences of these changes may not be immediately visible, but the underlying forces are building. It's a slow, invisible process, but one that is undeniably shaping the future of the region. As we continue exploring the profound impact of climate change on the geological shifts occurring in South America, it's essential to understand how the interconnectedness of environmental factors amplifies the forces at play. The warming of the planet doesn't just affect the climate in isolation. It triggers a cascade of changes that reverberate through the land, ultimately affecting tectonic movement and contributing to the growing rift in South America. Take, for instance, the phenomenon of permafrost thawing, which, while more commonly associated with the Arctic regions, is beginning to have an effect even in higher altitude areas of South America, such as the Andes Mountains. This area, known for its steep, fragile landscapes, is home to vast glaciers and ice fields that have existed for centuries. However, with the rise in global temperatures, these glaciers are receding at an alarming rate. As the ice melts, it not only releases vast amounts of water but also contributes to the destabilization of the soil beneath it. Permafrost, which had kept the Earth solid for millennia, is now becoming more unstable. This release of pressure can cause the surrounding rocks and soil to shift. It's a process called deglaciation-induced subsidence, which weakens the ground and creates conditions ripe for tectonic activity. Interestingly, while the rapid retreat of glaciers has primarily been seen as a byproduct of warming in the polar regions, the Andes are experiencing similar challenges. This glacial loss weakens the support for the mountainous structures themselves, creating a slow but steady pulling apart of the Earth's crust. In a way, the loss of ice is facilitating the very rift that's emerging between the South American plates. The meltwater that accumulates also exacerbates soil erosion, further compromising the already fragile land in these regions. What was once a tightly compressed region, with glaciers pressing down on the Earth, is now opening up, leaving room for faults to be more easily activated. Moreover, as temperatures rise, these rapid changes in glacier mass also affect the surrounding ecosystems and human settlements. In certain regions, people rely on the slow melt of glaciers to supply their fresh water, and as the glaciers recede, communities are left without a sustainable water source. As this water runs off and saturates the land, it amplifies the risk of landslides, which further destabilize fault lines and rifts. When the ground becomes overly saturated from floodwaters, even slight tremors can result in larger shifts as the land begins to lose its cohesion. Another, perhaps more subtle, way that climate change is influencing geological activity is through the gradual rise in ocean temperatures and the accompanying increase in oceanic evaporation. While it's easy to focus on the visible effects of this on weather patterns or sea levels, one must also consider the hidden effects it has on the tectonic landscape. The high temperatures can affect the cooling cycles of the oceanic crust, particularly in the Pacific Ocean. The Pacific Plate, which is constantly subducting beneath the South American plate, is part of a delicate cycle of cooling and heating. As the oceans warm, the rate of cooling for the oceanic crust decreases, which can lead to an increase in its buoyancy. A slight change in the buoyancy of the Pacific Plate, combined with the immense pressure from the Earth's core, can result in a shift in the interaction between the two plates. This alteration can cause a fault to shift along the Andes, contributing to the overall instability of the region. An interesting phenomenon occurring along South America's west coast, particularly in Chile and Peru, is the emergence of new geothermal activity. As the heat from the Earth's core interacts with the warming oceanic plates, new geothermal fields have begun to form. While geothermal energy is an invaluable resource, the activity associated with these fields can also place increased pressure on fault lines, contributing to seismic activity. This kind of volcanic or geothermal movement has historically been linked to earthquakes and rifting activity. Now, with the added complication of a changing climate and increased temperature fluctuations in the region, this could be contributing to the growing crack along the continent. The role of human-induced climate change cannot be understated when considering the amplification of these natural geological processes. As industries, agriculture, and urbanization continue to expand, particularly along the Andes, the pressure on the land grows. Mining, drilling, and deforestation activities in these areas add further strain to the environment. In particular, the extraction of fossil fuels and minerals in the Andes has become a significant contributor to local soil and land destabilization. The removal of natural resources from deep within the Earth's crust can create voids and weaken the support of tectonic plates, making them more susceptible to shifting. Similarly, the deforestation occurring in the Amazon region has massive consequences for the structural integrity of the land. The Amazon rainforest, often referred to as the lungs of the Earth, plays a crucial role in regulating the region's climate. Without the massive root systems of trees holding the soil together, the risk of erosion increases, particularly when combined with increasing rainfall from intensified storms. As the land becomes more prone to erosion, sediment is washed into rivers and oceans, which can cause shifts in the Earth's crust due to the redistribution of weight. The instability created by this process could ultimately exacerbate the tectonic stress already present, contributing to the widening rift splitting South America. To further add to the complexity, we must consider the growing concern of methane emissions from both human and natural sources. The thawing of permafrost, as well as the disruption caused by deforestation and urbanization, releases large amounts of methane into the atmosphere. While methane is a potent greenhouse gas, it's also an indicator of underground processes. As methane accumulates in pockets beneath the Earth's surface, it can contribute to the destabilization of the land, acting as a catalyst for seismic activity. This is particularly dangerous in regions like the Andes, where tectonic pressures are already high. The story unfolding in South America is one that paints a picture of interconnected forces, human, natural, and environmental, all coming together to reshape the continent in ways that may seem improbable but are becoming increasingly plausible. While the rift in South America may appear to be just another geological oddity, the underlying causes are anything but ordinary. They are the result of a world changing at a rapid pace, fueled by climate shifts, environmental changes, and human intervention. Each of these factors plays a role, adding to the pressure on an already unstable region. And as we continue to witness the world around us change, it becomes clear that understanding these causes, both natural and human-made, is key to comprehending the full scope of what's happening beneath the surface. As we look to the future, the question remains, how far will this crack go, and what will it mean for the future of South America and the rest of the world? As we draw our exploration to a close, it's important to reflect on the incredible complexity of the forces shaping South America's rift and the surrounding region. We've delved into the various causes that seem to converge at this one particular point: climate change, shifting tectonic plates, human impact on the environment, and even the deep-reaching effects of industrialization and deforestation. While these forces may appear disjointed at first glance, they are all deeply interconnected in ways that continue to surprise even the most seasoned geologists. What began as an environmental concern is rapidly morphing into a larger and more pressing issue that carries with it profound implications not just for South America but for the entire planet. The rift in South America is not just an isolated geological occurrence, it's a visible testament to the broader changes we are seeing worldwide, reminding us of the fragility of the Earth and the delicacy of the balance between nature, climate, and human activity. This monumental crack splitting the continent is a warning. It's a reminder of how small changes, over time, can grow into significant events that forever alter the world we know. But it also serves as a call to action. As experts continue to investigate and monitor the situation, it's vital that we all remain conscious of the environmental shifts we contribute to and the legacy we leave behind. The future of South America and other regions facing similar threats hinges on our ability to understand these complex factors, recognize the potential for catastrophic events, and take proactive steps to protect our planet. Whether through combating climate change, improving our approach to urban development, or reevaluating our resource extraction practices, we all have a part to play in preventing further instability and ensuring that the Earth's natural processes are allowed to function as they were intended. It's clear that our modern-day actions will be judged by the generations to come, and how we respond to challenges like the rift in South America may define the resilience of our planet for years to come. As we consider the potential long-term effects of this growing crack, we must keep a watchful eye on the shifts happening beneath the Earth's surface and also recognize the part we play in it all. In the face of uncertainty, it's easy to feel small in the grand scheme of things. But every effort, no matter how small, toward protecting our environment, curbing emissions, and preserving the delicate balance of our ecosystems contributes to a greater movement. The rift may be just one manifestation of the bigger picture, but it is a powerful one. It calls on us to take responsibility for the world we've inherited and ensure that future generations don't bear the consequences of our inaction. And as we continue to unravel the mysteries of our planet, we invite you to stay informed, stay curious, and stay engaged. If you want to keep up with more incredible insights and intriguing discoveries like this one, be sure to subscribe. Join us as we explore the world's most pressing issues, the stories that matter, and the changes that shape the future. Your support helps us bring more compelling content to light and ensures that we can keep bringing you the information that matters. So, please consider subscribing, and together, we can continue exploring the mysteries of our world. Thank you for joining us, and until next time, stay curious, stay informed, and stay connected.